How's that? How's that? Yep, okay. Hang on, I can hear myself. Right. Okay, right, sorry about that. All of my carefully prepared words have flown out the window as soon as I've looked at you all. It's great. Okay, so I'm Dave. Nice to be here, thank you. And for more years than I care to think about, I've been building this game engine called Indigo. And my philosophy was kind of like, if I build it, they will come. There must be loads of Scala developers who want to make games and fun things in Scala with this language that we love so much. Surely they're bored of shoveling strings over the internet by now. And some people have turned up. People have arrived on Discord and showed us amazing things they've built. There's kind of two kinds of those people. Some of them already know what they're doing. Quite a lot of them already do. And all they do is they turn up and say hello. And then at some point they'll just post a really cool screenshot and they'll be like, that's amazing, fantastic. It doesn't happen very often, but it does happen. It's great when it does. And there's another group who are, they're a little bit more, I don't really know how to start. I'd like to have a go, but this is a bit scary, so I'm not sure how to do that. So what I wanted to do today really was try and offer like an on-ramp into having a go at this stuff, right? So we're not going to go really deep, we're going to go quite broad, and I'm probably going to run over time, so I apologize in advance. But here we go. So you're a Scala developer and you fancy building a game, right? Having got over the disappointment that you're not going to build the next Grand Theft Auto by yourself, what do you do? Well, I think that probably most Scala developers are a little bit, probably a little bit worried about art, right? Even if you can do art, right, and art being graphics or audio or game design is also art, right? Even if you can do it, it's quite a time sink, right? How do you get in without that investment, right? And I think that the low-hanging place that you go to is something like classic arcade games or simulations like Conway's Game of Life, perhaps, right? And these things are amazingly good to learn how to do. If you're going to learn how to build one of these, you'll learn loads of stuff. It's really good. The problem is, not to put too fine a point on it, nobody cares, right? I've built Snake loads of times, and every time I show they go like 3 seconds of nostalgic bliss. It's Snake, look at that. Okay, and they've moved on, and they're more interested in the code and how it works than actually playing the game, right? So we need something else, right? New criteria. So I want to keep my low art criteria for getting started because I don't want to get bogged down in all of that stuff. But also what I want is like a game archetype that I can scale, right? I want something that can be tiny, like a little puzzler, and it can go all the way up to something truly enormous. And I also want, because I'm a programmer, and I want to have lots of fun writing code. I want to have interesting things to code when I'm building this thing. And the other thing that I need is a community, right? I want people who actually want to play my game, not people who are just going to look at it and go, oh, that's cute, right? I want people who are going to want to try it and give me feedback and let me know what they think. And also I need, that's fine, a community of players, maybe even people who will buy it at some point, that would be nice. But also I need a community of builders, right? We are a community of builders, right? And if I want to know what a monad is, you're my people, I'm going to come and talk to you, right? But if I want to know how to build a combat system or how to do procedural generation of dungeons, maybe there's fewer of you here who know how to do that. So my proposal for this is a genre of games called roguelikes. We're going to look at roguelikes today. This is not going to be everybody's cup of tea, and that's okay. I think I myself, there's some roguelikes that I really love playing, and there's some which I'm kind of not so fussed. But I actually find that I enjoy making them more than I enjoy playing them quite often. But I think that's fine. There's, just because you happen to like, multiplayer first-person shooters doesn't mean you're going to be any good at them at all. And roguelikes have a lot of characteristics that I think that we can relate to. They're very data-driven, lots of fun stuff. So, what is a roguelike? Your game is a roguelike if it is like the classic game Rogue from 1980. This is it in all of its ASCII glory, according to Wikipedia. So the general what roguelikes are like is they are procedurally generated dungeons. You kind of wander around them with your little character. You collect stuff, you fight things, and you die repeatedly. Dying is a very big thing in roguelikes. And when you die, you start right back at the beginning with nothing. It's called permadeath. And I found that rather off-putting at first. I thought, that sounds that's a bit much. I'm used to my warm and fuzzy games with meta progression, where even if I die, I've got a bit more experience and I'll do better next time. I've come to think of them as being a little bit like, and I don't know if the roguelike community would approve of this. I'm kind of comparing them to chess, right? Because in chess, when you start again, you don't start with anything new, but you are better than you were the last time you played, and you're going to get further. And the fun of these games is in the exploration and the mastery of them, okay? Okay, here's a few commercial, in quotes, successful, definitely successful, dubiously commercial roguelikes, just to show you that they do exist and people do buy them and things like that. This is Dwarf Fortress. This is, I was talking earlier about games at scale. This game has been in development for 20 years. It was free up until quite recently. It probably still is, but you can also buy it to fund the developers. And this thing is just absolutely imposingly massive. It will generate thousands of years of history for your land before you even start the game and stuff like that. It's too much for me, but it's much loved. This is more my speed. It's a little mobile game. So this is Hoplite. It's a puzzle. It's a roguelike you can get on your mobile phone. It's free of charge up to the first 16 levels or so. And this is the game that got me to understand the genre, that I really started thinking, oh, this is actually quite good fun. Because I played it for a while and I went, game, wandered off, came back, picked it up, and I did something different, and a different outcome occurred. And I thought, oh, there's the fun. There are different tactics here that I hadn't seen before. It's like a puzzle. You have to work out how to play this thing. A couple of other honorable mentions. Cogmind is you notice these are all kind of 1- and 2-man teams are building these things, which is quite encouraging. Cogmind is by a guy called Josh Gee. I hope I pronounced his name correctly. G. And he turns up all over the place in the roguelike community. And I think that his stuff, even though there is a tile version and an ASCII version, I think it's absolutely gorgeous, actually. It's so pretty the way they've done all the animations. It's a bit like playing in the Matrix or something. It's fabulous. But he's also spent an awful lot of time working on the usability of these things, because traditionally they were very keyboard-driven, ASCII, hard to understand. What am I doing? And this one's much more friendly. I also wanted to mention Pork-like for 3 reasons. The first one is it has a funny name, and I quite like that. The next one is it was made by a guy who, it's for the Pico 8, and it's made by a guy who has done a YouTube series on how it's constructed. But more importantly, I kind of wanted to look at the graphics, right? Later on, we're going to see something that's a little bit like this. But this one also has a completely different style. It's quite simple, but it's really effective, I think. And that's going to be important later. Okay, so enough of that. This is where things get awkward, because now I have to type and hold a microphone. We're going to try and make a little bit of a roguelike in Indigo. And I did promise that there wouldn't be too much art. So this is all of the art. Okay, we're going to use Indigo and an extension called the Roguelike Starter Kit, which is the only extension that Indigo has, which I made. And what it does is it provides a sort of terminal emulator for Indigo, so you can write TCOD-style terminals applications in a functional game engine. The art, you can download more of these things. These are tile sheets for Dwarf Fortress. They come from the Dwarf Fortress tileset repository. And they are based on the IBM code page 437 extended ASCII, snappy title, tile sheet. But lots of them, they all have different styles and stuff about them. And the pink color in the background is the mask color for the background. And the Roguelike Starter Kit knows how to deal with all this stuff. Okay, so we're going to try and build this. Let me just get set up here. Bear with me. Okay. Okay, so I'm going to use this as an excuse to kind of walk you around. Is that working? Yay, there we go. Hello world. This laptop is woefully underpowered, so I apologize. It takes a minute for it to start. But we've just got a hello world at the moment. We're going to turn it into that little game that we saw a second ago. I'm using Mill today, you may notice. There's no reason for that. It's just subtle propaganda to get you to try it. Okay, so as promised, here is the artwork. That's it, that's all of it. I'm going to quickly show you the mill build just for the sake of it. So Indigo comes with plugins for SPT and mill, just the same. You can use Scala CLI as well, but we don't have the full whack of support that you get with the other two. In both cases, basically you have to define some options about what your game is going to be like. And we have some code generators, which manufacture codes. Basically, it'll list your asset directory and make it available in Scala directly, so you don't have to import it and read it at runtime. And it'll set up all your configuration. And there's also a bunch of helpers down here. Earlier on, you might have seen me run my roguelike.run game. It's running a mill command, which compiles, does a fast link, and runs the game using the plugin. So here's the code. Let me close that because we don't need it. Is that big enough? Are you okay? Yeah. Yes? Bit bigger? How's that? Nice. Got thumbs up at the back. Amazing. Okay. So there's I'm just going to walk you through the basic setup of what we've got, because this is how all Indigo games look like. It's following the Elm architecture, same as Tyrion and the talk that we're going to see next time, perhaps. There are 4 different entry points that you can use. You can make your own. I'm using the Indigo Sandbox today. There's also, which is the smallest, it's the most compact. It's just for noodling around and trying things out. There is also the demo one, which is a bit more full-blooded, and there's Indigo Game, which gives you scene management and stuff like that. The final one is Indigo Shader, which we'll see later on. The most important, so there's a load of setup, and here are the generated classes that we mentioned earlier. And here, from the roguelike starter kit, I have registered all of the shaders that I might want to use. But the main thing you need to know about Indigo games is that the interface is a bunch of pure functions, right? The Elm architecture works by essentially composing a few simple pure functions, not pure in the sense of IO effects monads, like they're not that kind of pure. Basically, it takes some arguments and you build a result based on that. It's a pure function in that sense. If you want to stray outside the lines and use a var, I'm not going to judge you. That's your choice. But the 2 that we care about mostly today are update model. You get some context in all cases, but basically your job is to take a model, which at the minute is just typed to unit. We don't have one yet. And based on the current events that are coming through, manufacture another model. That's your job here. I'll come back to the rest of it. We're going to put a model in soon, so you'll see what it's like. Present is the same thing. Take your model and manufacture a scene update fragment. Scene update fragments describe all the things you might want to render, or the sound, or any of that stuff, anything that you want to present, right? They form monoids, and they're quite good because you can kind of build chunks of it and slam them all together. There is this outcome type, which is a monad. And what it does is it essentially aggregates ordered events. So your job is to manufacture a new model, a new scene fragment to render, and collect events as you go, and all of those events are delivered to the next frame separately. So there's no events that are interfering with your game as you're running the frame. Here we have our hello world that we saw a minute ago, and I'm just going to explain how this is rendered. So it's using functions of the roguelike starter kit. This is the Rogue Terminal emulator, which is the slightly rebellious cousin of the Terminal emulator, which is the standard one. The standard one is using nice immutable data types. This one does not, but it's much quicker. So as long as you know that and you're careful, you're fine. This is definitely not an efficient way of doing this, but it's nice and simple for the demo. So we've built an emulator. It is 16 by 16 in size, and I've put a string in it. We then have to manufacture clones. This is how the terminal gets rendered. So whenever you're rendering entities in game engines, it's always trade-offs. What are you getting with this type that you're losing with that type? With clone tiles, what you get is the ability to render thousands and thousands of cropped versions of this all over the place with minor adjustment, but it is only minor, and you lose control over the depth and stuff like that. But it is efficient. And you have to provide a sort of archetype for what it's going to copy and modify as the thing to clone. And then at the end, we just build our scene update fragment, put in the clones, and register the blanks, which is the copies of this thing. Okay, so let's see if we can make it do something. Get rid of hello world. Right, I'm going to have to kind of duck or something because I can't do this. that's not a good start. Okay. Right, so first off, all I'm going to do is fill the entire screen with a dark shade, which is going to be red with a black background. Oops, Daisy. The dark shade tile is this guy down here. I don't know if you can see that. Let's go and run it. It's normally faster than this. I'm blaming Zoom, just so you know. Okay. Hey, there we go. Right. So what we're doing is normally in these games, you have these lovely procedural dungeons with corridors everywhere. We're just doing one room, okay, because it's a demo, right? So is that going to work? It's going to work. Yay. So what I'm going to do is I'm going to cut a little inset into that. So I'm going to put in a rectile, which is, you know, one down and 14 by 14. So it's just inside the other one. And I'm going to make it a light shade, which is a different tile. It's this tile over here. And I'm going to make it red with, I can't see the other part, it's going to be black though. And Indigo comes with a load of sort of helpers for like mixing colors and stuff like that. Wherever we've been using this a long time, me and Dave at the back there, who's my co-conspirator in all of this. And whenever we use this, we find these sort of lumpy bits of the API and we try and smooth them out with nice bit of nice syntax if we can. I'm also, for the sake of compile time, is going to stick in our hero. This is our hero. Can't you tell? In ASCII roguelikes, the hero is an @ sign, right? We'll make him look better later, don't worry. And he's going to be cyan with a transparent background. Let's run that one more time. Hey, great, there he is. Right, the only problem is we can't move him yet. Him or her, person. Hold on. So what I'm going to do, I'm going to talk a little bit, and then I'm going to do some typing because I can't hold the mic at the same time. So I'm going to introduce a model to this, and then I'm going to put it into the update loop, and we'll see it moving. Okay. Maybe I can duck if I need to. Okay. That's not working. Okay, so we're using some of Indigo's standard types, points which represent. So Indigo is a pixel art engine, so everything is in integers, right? Which is really inconvenient if you plan to not use integers or pixels. Tough. So most of the types are points, sort of point is integer based, rectangle is a rectangle of integers. There are other types for doing geometry type calculations that are based on doubles because Scala.js converts everything to a double eventually anyway. So here we've set up a model with a player in it, which is just a position. That's all we need for this little demo. A room, and I've made a floor field, which is basically contracting the room rectangle by 1, right? So I'm going to go and plumb that in. It's actually surprisingly difficult to do with a massive font. So I'm going to put the floor there, and I'm going to replace this one with the player. Okay, now in the Elm architecture, your model is usually a monoid, and that means that you have to provide. No, that's not really true. It's often a monoid, but it doesn't have to be. But either way, you must provide an initial state for the model at all times. So I'm going to, hold on. Okay. And if all is well, absolutely nothing will have changed. Perfect. Okay, right. Now to make it move. So what we need to do is update this part here, which is the model update function. Basically, we need to listen out for keyboard events and do something appropriate when that happens. Hold on a second. Right, I'm sensing you'll be pleased to know this is the only live coding part of the demo, so don't worry. Okay, what we need to do here though is we need to produce a new model which has the new position in it. And the traditional way to do that with roguelikes, or as far as I can tell from my experimentation, is to manufacture a bump function. So most of the game's logic is actually based on bumping into things. These are not terribly complicated games, right? So you're walking around, if you bump into a wall, you don't go anywhere. If you bump into the floor, you walk onto the floor. If you bump into a bad guy, you kill it. Bump into a door, you open it, right? It's that kind of thing, right? So I'm going to write the bump function. And that is it, hopefully. So all we're going to do is we're going to match on the point. The point is going to be a relative point, so it's just going to be an up, down, left, and right. We check with the floor to say, is the point within the rectangle? If it is, it's good to go. We can add that to our current player position. If it's not, it's a wall, do nothing. Oh my God. Okay. That part of my screen is covered, but I think you can see what I'm doing. And hopefully if we run it again. There he goes. Okay. So naught to moving thing in a few minutes. It's not bad, right? Not bad. Okay, back to the talk. You'll be pleased to hear. So we've done that. That's great, right? All we need now is like all of this stuff. Non-player characters and levels and pathfinding and dungeon generation and collectibles and health potions and puzzles and all sorts of stuff. And there's no way I'm going to get through that next 20 minutes, right? So I'm not going to try, right? At this point, I'm going to hand you over to that community I mentioned earlier. So if you look right in the middle, there's a big link. With roguelikes, there is an official set of tutorials on how to make roguelikes, and they will teach you all of that stuff, right? Which means you don't need me to teach you it. I'm going to go on to more of that in a second. The link, the little box at the top, there is a roguelike dev subreddit, which is really friendly. The guy who built Cogmine, Josh Gee, I hope I pronounced his name correctly, he runs that, and every year they do or he seems to, every year they run a roguelike dev does the complete roguelike tutorial, which is a bit like those office book clubs you have, where every week you go off and you do a chapter and you come back and you share screenshots and compare algorithms and all of that good stuff. It's very nice. And I did that a few years ago. More on that in a moment. They have a conference, the Roguelike Celebration, which is apparently really good. I've seen a few of the talks. They were pretty good. I haven't been to the whole thing though. And coming up in March, they have their annual 7-day roguelike challenge game jam. So if you fancy having a go, here is your big chance. No pressure. But it would be awesome to see a whole load of Scala entries this year. That would be cool. So what I wanted, the reason that might look like a cop-out, but the reason that I'm showing you all that stuff is to say there is support, right? This was my effort doing the roguelike tutorial follow-along a few years ago. There's a link at the bottom. You're welcome to go and look at that. It has every chapter of the tutorial that I did in Indigo. The code is utterly terrible. You've been warned. It is the illegitimate child of mutable Python with functional Scala in an Elm style, right? And it doesn't work very well. It's all it has been reworked since then, and it's a lot better now. But I haven't touched that. I've left it there in all of its glory. But when I finished doing this, I had a really good time doing this. I learned loads of stuff. It was brilliant, right? And I would hardly recommend doing it. Somebody sort of twisted my arm at my back to do this, actually. It was somebody on our Discord server said, we should try and do that. And I went, oh, okay then. I wasn't really all that interested prior to that. By the time I'd finished, I built this wonderful thing. It's actually a lot more fun to play than it looks like it is. And I was left with this question, which was, okay, well, now what? Right, which is what we're going to talk about for the rest of the talk. So this is my attempt at ASCII art humor. The elephant in the room is that I can't tell that that's an elephant because it's ASCII art, right? And the issue here is that ASCII art kind of looks cute, and then there is some really interesting modern ASCII art, which is worth Googling. It's safe to Google. That sounded terrible. But the problem is it's not very accessible, right? So you look at it and you go, well, if you don't know what all those weird characters mean, like, do you know that that's supposed to be the hero, the @ symbol? Do you know what a semicolon does? I don't. And you have to know all the keyboard shortcuts as well. So how do you go from there to something that, like, my daughter will play, right? That's kind of what I was trying to get at. And that's what we're going to do. So this is, these are the same game. I built the first one, the one on the left first, and I ported it to the one on the right. And I know that I promised there wouldn't be much graphics, but there isn't. Bear with me. So the difference here between these two is about 5 times the code. The one on the left is just as boring and annoying in many ways as the one on the right is when you try and play it. They have the same gameplay problems, which I've now remedied some of them. It's never going to be great because it's just a demo. But I was kind of copying the sort of hoplite aesthetic where they don't have animations of people moving. It's just like sliding along. And it's kind of like a little puzzle game. So I've put this slide in literally so that I remember to show the demo because I keep forgetting. Oops. It's called hoplite because it's like hoplite. And here we go. I don't know if you're getting any sound here. Oh, no. I'm hoping the sound in the next talk is going to be better than this, Paul. So yeah, so the game is really simple. Get from one corner to the other, and that's it. And every time you go down a level, more bad guys appear, and you can just try and run away. That works perfectly well up to a point, and then they sort of gang up on you because there's too many. And if you, it's sudden death. So whoever hits the other wins. Sometimes you're stuck, you need to escape, and so I put in a special move, especially for my daughter. It's a big rainbow. Look, you can jump, but you can only do it once per level, right? Thank you. Okay, so what we're going to do is quickly go through some of the things, the process I kind of went through to make that version of the same game, right? So we're going to start with some quick wins, look at lighting quickly, animation, term management, and shaders. This is going to be quite quick, don't worry. So quick wins. I told you there wasn't any more art. It's the same thing, right? I've put in some pixel art over the top of the existing tile sheet. You don't have to go as complicated as this. It's not that complicated, but you don't have to go as complicated as that. But it's essentially being rendered in exactly the same process. It just looks better because there's a bit more graphicalness to it. So it's easier to, and the point really here is to inform the user as to what's going on, right? So I want people to understand that's the hero, that's the bad guy, those are the stairs, right? quick win 2 is essentially changing the way we render it. So the background is fine. So the image on the left is what happens if you just render it using the terminal emulator, right? It just draws the main character in a box in amongst all the background tiles. You don't really know what's going on. So what we can do is we can first of all lift the character onto a separate layer just by rendering as a graphic, leave the background to be rendered by the terminal emulator. That works fine. That instantly lets you use the transparency to see the grass underneath or the tiles or whatever it is. There's a little thing called a reference point, which is what that white cross thing is. And essentially what that says is it tells Indigo that there's an offset. So instead of rendering it, when I say render at 0, 0, if there's a reference point, 0, 0 is wherever the reference point is, and you can artificially shift the character. And that allows you to move him just slightly out of the grid so he looks like he's actually standing in the middle of the tile, not slapped onto it. And then eventually sticking a little semi-transparent circle underneath it gives him a little shadow, so he's got a little bit of weight, right? Not that complicated, really, just a few little steps. Quick win 3 is sound, and it's a quick win because Indigo's sound handling is terrible. I'm an amateur game builder, I'm an amateur engine builder, I'm definitely not an audio programmer. So what you can do in terms of audio is you can fire up events which play individual sounds, which is how I was doing those wonderful bleepy ploppy noises earlier. And you can also, on this scene update fragment, add an audio track as a background if you want to. Even adding funny little low-res 90s sounds actually adds a lot to the game. It's quite surprising. So it's worth the investment. Lighting. So this is a comparison lit and unlit. Lit on the right, obviously. Do we need to do this? I don't really know. Is it adding anything? Dubious. I was trying to add some lights to show where you're going. So you start in the dark and you work your way towards the front. But I really just wanted to do it so I could show you how it works in Indigo so you can have a play yourselves. This is not pixel art in the 90s, right? This is pixel art of modern day, and it's all rendered on modern graphics hardware. And modern graphics hardware doesn't even know what a pixel is. So it's quite happy to light anything you tell it to light as long as you give it the right textures. Here are the textures. So the one on the left is what's called a diffuse, which is basically our color background with some shading on it. The next one is the emissive. So I wanted all the eyes to glow in the dark. It's not really dark on there, but basically their eyes always glow. And then I made a little height map, which is pretending to know what the depth is. And then if you use a little online tool, and there's loads of them out there, you can convert that to what's called a normal map. If you remember back to your school days where you were learning about angles of incidence and reflection, they all bounce around this thing called a normal, right? And all that you're doing essentially is encoding the bend of the normal into the red and green channels of the image. And that tells it when the light hits, bounce at a slightly different angle. With those, you have to actually apply them. So to receive dynamic light, we have to set up a lighting model and give it to the material, along with the emissive and normal textures. The diffuse texture was already on the graphic. And then we have to add the lights. So I went with 2 big point lights, one which is over the exits, the other one's right in the middle. There's a direction light, and there is a ambient light to give us some general light to the scene. This is how you add them. Everything in Indigo kind of looks the same. It's all pretty simple in terms of the APIs. And that's it. Animation. This is my little naked guy. He's been with me since Indigo started. I kept meaning to give him clothes, but I've got to the point now where I quite admire his confident stride. So I'm using him again. Animation in functional programming is really interesting. And the things that I know about it, I kind of read a paper years ago on FRAN, which is functional reactive animation. But I'm not trying to do all of that. I'm just trying to give you enough tools to get started. The general idea is you have a function, which is the time in seconds, and it produces a deterministic value of a, right? Doesn't have to be an image. It can be anything. So that thing in the middle could be a crossfade for a piece of audio, right? Why not? But if you imagine that you are going to scrub down a timeline of your favorite movie, if you get to a certain time, you expect to see the same frame every time. It'd be very weird if you didn't, right? That's how it works. In Indigo, these are signals. So this is a very simple signal. It does a pulse, and I'm using it for the little retry flashing thing in the corner. So you set up a signal, you tell it that you want it to pulse every half a second. Here I'm mapping over it. I'm not producing an animation frame, I'm producing a string, which is either empty or not. and I'm giving it the running time of the game from the context object. I don't care here when the animation starts. So it doesn't really matter when I'm playing it because it's just flashing. Nobody will notice the difference. This one is a little bit different. So here I'm using a blend material to desaturate when the player dies, right? In Indigo, everything is rendered either in terms of an entity or a layer, right? Entities are all the little things that are on the screen, and they are sitting inside layers. Layers are a bit like Photoshop layers, so you can decide how one layer gets crushed onto the layer below it during the flattening process, right? And you can write your own custom shaders to do pretty much whatever you like. So in this case, I've got a linear signal, which over the course of 1 second goes from 0 to 1. I've mapped over it to flip the value around, and I'm using it from the time of death, so it's context running minus time of death, to give us our fade out at the point when I get killed by a bad guy. Signals come with signal functions. So you can use signal functions. These are combinators. So if a signal is a function from seconds to value A, a signal function is a function of signal A to signal B, right? And they're very handy. You can use them for building all sorts of things. There's some standard ones like orbit, which is in the middle here. So this bottom bit of code here basically pipes the current time into a orbit signal function, which is then calls and then to move a circle onto the position of the orbit, right? However, that's really difficult for building complicated animations. So we also have a DSL. And the DSL is not terribly well illustrated here, I apologize, but essentially what it lets you do is say things like start after, pause for a while, and then when you run it, give me the last frame of the animation, even if you're way beyond the animation time and stuff like that. So it's almost like doing timeline animation in Flash or something, if you ever did that. I'm using it to do the movement of the character. Okay, turn management. When you add animation, things get really complicated for quite a few boring reasons. When we're doing the ASCII version of this game, when you press your arrow key to move, to bump into the next thing, basically everything happens all at once. So you move, you press the key, the player moves, all the enemies are updated, and we're just waiting for the player again. It all happens faster than the human is going to press the key. I like to call it meat time, right? How long it takes a person to hammer the keys. So that's really simple. And this is a slightly different version of the bump function, which is emitting events instead of new versions of the model. But it all happens pretty simply. As soon as you add animation, well, the point is to explain to the player what's going on. That's why we've added the animation. So we need to wait for the player input, update the game model when the player does his thing, animate the player, then update the game model with the enemies, and then animate all the enemies so the player has a chance to actually see them move and understand what's just happened in the last bit. Then we start again. To do that, we have to do state management with a sort of finite state machine, and I'm going to very quickly show you how that works. Don't worry, there's no typing in this. I'm just walking you through some code. It's not very complicated. So here are this is nothing to do with the game. I made some traffic lights for you. Zainab requested pixel art. Here is your pixel art. So when you press space, it flicks through the traffic lights. Okay, nothing complicated. Let's have a look at the code. Is that still the right size? That's not bad, is it? So the way this works is here is our states. It is an enum. Everything is Scala 3 here. So we have red, amber, and green. There's a little next function, which does the obvious thing. You could use phantom types and stuff if it was more complicated, if you want to. I haven't bothered here. And I have a little event which is called next state. And I have a next function on my model, which just updates it with the right state. The rendering is done based on the state in the model, i.e. my traffic lights. And all it does is it chooses a crop and it applies the crop to a graphic. Every entity, as I said earlier, has different trade-offs for rendering or whatever it's doing. Graphics party piece is that you can crop it, right? You can tell it to just render a part of the image. So I'm just choosing which part of the image to use. Is that going to work? Yeah, this is the actual source image. close that again. And all that happens is in the model update function, we wait for our spacebar press, add a global event saying global event next state. When the next state is picked up on the next frame, model.next, and we're done, right? Easy peasy. Clearly, in this case, I could have merged those two things together. The point really is that sometimes you are kind of deep into your logic somewhere, and you need to tell something back at the top to do some work, right? And that's why we would use an event in this case. It's clearly inefficient in this scenario, but it's very useful when you're scaling out your application. And finally, we're on to shaders, which is definitely my favorite thing at the moment. Did you notice there was no rainbows in the tile sheet? And yet we have a rainbow. It's a shader. I could have made a rainbow on there. Of course I could, but then I wouldn't get to show you how it works. So what is a shader? So for the sake of this talk, we're going to tell a lie. And we're going to say that a fragment shader, which is the one that's used to decide the pixel color, is basically a parallel map over a list of coordinates on the screen, pixels, if you like. And because it's a parallel map, you can't rely on knowing what the thing next to you and above you is. You just have to decide what your own color is going to be based on some context and your coordinates, which is in the context, and you're choosing a color value, right? So it's basically a pure function, takes some context and decides a color. Right? So this is all maths, right? But it's not, it can be very complicated maths, but I'm not going to do any complicated maths today. You don't have to be a wizard to do this stuff. So here is a, oh my gosh, why does it keep doing that? Let's have a look at a basic shader. Basic. So this is just some pretty colors, which are kind of like the indigo colors, which I quite liked. Let's see how that works. Okay, so as promised, we're using the indigo shader entry point this time, because this is really just for noodling around with shaders, right? If you're doing, there's a thing called Shader Toy, which is great fun if you're a shader writer. And this is kind of like emulating that a little bit. But all of the shaders here, so the shaders, all the code that you've been seeing so far is actually Scala.js. Shaders are written in a language called GLSL. But we're using Ultraviolet, which is a Scala 3 to GLSL transpiler to write all of our shader code in Scala, right? And in this case, all we're going to do, I should walk you through this, I suppose, but there's not much to say. It's kind of filling in the blanks for some of the defaults for Indigo games, what they need. And here we're saying which shader to use. The shader is telling it which environment that we care about. So you can have a custom environment if you want to. This is the default, so it includes things like the time, the running time, current UV coordinates, all that sort of stuff. And what you have to do for a fragment shader is manufacture this fragment function. And all we're doing is building a vec4, which is a 4-component structure, which is X, Y, Z, and W, but it also works for RGBA, right? Also stands for RGBA. There's lots of, in GLSL, there's lots of fancy little constructors to make it easier to work with. So vec2 is really UV is really a vec2. So here we've inserted a vec2 and 2 single components to build it. All we've done is plugged the UV coordinates, which are a value 0 to 1 in both directions, into the X and Y position, into the R and G position, really, and given it a blue value of 1. Okay, something more complicated. Ooh, hang on, back to my talk. We need to make a rainbow. The way we're going to do that is we're going to use a thing called, we're going to use 2 functions. One is called step. Let's have a look at step. This is GraphToy, also great fun if you're a shader person. So step, all that step does is there is an edge value, in this case 0, and the X is proceeding along this line, and when it gets to the edge value, it changes from outputting a 0 to a 1. That's all it does. So if I make that be 1, it'll move along a little bit. Okay? Now, because of the handy colors that GraphToy comes with, I can actually make a rainbow in GraphToy straight away. That's not bad. The only thing I need now is some way to mix them all together. And there is a function called mix. How convenient. Let's go and have a look at that. So here is our little step function. There it is again. I've created a sine wave. There's no particular meaning to these. They're just for demo purposes. A sine wave and a cos wave and another step. But this step is based on the time. Might be very small, I'm not sure. Sorry if it is. The time multiplied by 2 to make it a little bit faster. And that becomes our step value. So it gives us that nice smooth sort of flow backwards and forwards. And then if we replace all that with mix, which is calling function 1, 2, and 3, it blends the waves together, right? And we do a lot of this for mixing colors and so on in shaders. So here is the rainbow shader. You know what it looks like. I shall not run it. I forgot to mention there was a huge debate in our household about whether those were the right colors for a rainbow. My daughter was adamant that I got it wrong. Later on, she gets her way, though. Don't worry. Okay, so I'm not going to go through the whole thing because I suspect I'm running out of time. But these are our step values that we saw before. Here I've encoded the colors as vectors. And here I'm doing the stupidest possible implementation for mixing all of that stuff together, where essentially we mix red with orange, orange with yellow, yellow with green, green with blue, cyan, purple, etc. Right? Purple is just like the background color; it's the default. And then at the end, so that's just a function. It's just a nice little function. And at the end, all we do is we supply the x value from the coordinates. So as we go along, we pick the right color. And for cuteness, I've kind of softened it by giving it a default value of at least 0.3, sorry. And then I've multiplied the new color value by 0.7, so it comes out a little bit softer. It's a little bit nicer. And here it is. Food for thought, though. So we've manufactured a function that takes a floating value, which naturally clamps but from 0 to 1, and we produce a color. But nowhere does it say that this thing has to go in a straight line, right? We just happen to be doing it for this game. And that's kind of the end of my talk. And this is where my daughter gets her own way with her own color choices of rainbow. She was very insistent. This shader is about 130 lines of code. Yes, I really just wanted to try and show you some of the stuff that can be done with Indigo and Scala.js generally, and hope that you'll give it a shot. And if you do, try and show somebody. Come join us on our Discord board and post screenshots and stuff, even if you think they're terrible. We'd love to see them. Right, thank you. Shall I stop there?
Right, thank you very much. Yes, there is an Indigo Discord. It's very fun. So do we have any questions? Oh, okay. Oh, we have 2 microphones. Are they both on? Okay. All right.
There was a hand. There was a hand over there.
I know it's Shah. He always asks good questions.
Hi, Dave. Thanks. Thanks for your talk. It was really interesting. I realized that like library developers and application developers tend to be 2 distinct group of people.
You're going to have to hold it a bit closer, I'm afraid.
All right. Can you hear me now?
Yes.
Okay, cool. So what I said was I appreciate that library developers and application developers tend to be 2 distinct group of people. So I don't actually know if you have had much of an experience writing games with your engine. But yeah, I wonder what the implications of the choices of like functional programming and Elm architecture or whatever is on the game development experience. Because game development tends to be like a labor of love. You tend to spend a lot of time on it, and it could be sort of overwhelming. And if you don't have the right setup, you could just get burnt out. So on a personal sort of development experience, how that sort of shapes things. But also, again, another implication, another sort of aspect of this is that could be a very big thing that you're implementing, and I'd like to know if functional programming helps with sort of splitting, like shaping the way you sort of, in enterprise development, like we start with interfaces and we mock things, and there's a certain way of sort of starting with POC and then developing that and changing that. And if functional programming helps that, so shapes that.
So the question is, does functional programming help with game development? There was a wonderful blog post years ago, which is where all this started, called A Worst Case for Functional Programming. And it was by a guy called James, whose surname I forgot now, I apologize to that person, who basically explained that his view, he was a game developer, and his view was that programming eliminates huge classes of error problems in terms of understanding the structure of the application, the event flow, what's impacting what, and all of that good stuff. And I was really inspired by that, and that's really where Indigo came from. I've recently written a terrible physics engine, which has made me question all my beliefs in that. But as a general concept, I think it does work. It is, especially with the Elm architecture, it is actually really quite easy to understand what the flow of your application is. So the initial use of the Elm architecture and functional programming in terms of developing games is very pleasant. Like, you can knock up a small game very quickly and you're like, oh, look, it's very pretty. It works really nicely. There's no weirdness. There's no strange state being altered or misunderstandings about when that event arrives and that kind of stuff. There is a point slightly beyond there where you try and build something bigger, and learning how to scale the application takes a bit more thought, right? But there is a pattern for that too, which I can talk about some other time. But I still believe that it's, I still think it's better. I used to be a Flash developer, and I used to make games in Flash, and this is way better than that. I mean, I'm not saying my engine can do better than Flash could do, but the experience of it for me is much better in terms of the patterns and the architecture. Is that okay? I've got a nod. Anybody else?
Cool. We have time for one more question. So,
thank you. Yeah, thank you for the talk. That's amazing. What kind of what do you produce out of the engine? Like, can you play it in a browser? Can you play it like on a cool machine? I saw Electron. So is that just compiled to JS and then ran using Electron? What's the backend?
Yeah, so at the moment, Indigo is entirely Scala JS and runs on WebGL 2. There is, so the reason for doing that is I'm, apart from Dave there who helps me at the back, I'm more or less on my own, apart from occasional contributors, which are much appreciated, thank you. But what I was trying to do was limit the scope, right? I thought I can't please everybody, but if I build it in JS, I can run it basically anywhere, right? I can use Cordova for mobile, Electron for desktop, runs in a browser. You can publish Indigo games to GitHub trivially, right? And that all works really, really well. There are dastardly plans to bring Indigo to other platforms because the notion is if we move Tyrion, which is another one of my projects, and Indigo together, Tyrion becomes the runtime. Then all we have to do is replace the runtime with something that understands a different platform, and away we go, right? It's not that simple, because WebGL gives you a really good abstraction over the graphics hardware, right? So you only have to learn, okay, you've got to look out for browser weirdnesses, but but basically one thing works everywhere. As soon as you start going to different platforms, systems, using Vulkan, Metals, God knows what, there's a lot to learn for the developer as well as the engine builder, right? And that's slightly worrying to me because it might be off-putting, in fact. But at the minute, you can run it on basically anything. It's just that it's JS. Bearing in mind that this is a pixel art game engine for games that look like they were made in the 90s with some slightly fancier graphics on the side, I think that's plenty fast enough. Is that okay?
great. Thank you very much, Dave. Big round of applause.